So we're back here today with my favorite ice chest air conditioner and what may be my worst idea yet. I'm Alex, and welcome to the Renaissance Builder. So to specify what I'm talking about is I had this idea to attempt to turn our ice chest or chiller-based ice chest air conditioner into a heater. Basically heating up the water that it circulates through the radiator to see if we can't turn the thing into a space heater. Now the reason I say worst idea yet, because I'm not sure how it's going to work out yet. I managed to test, so I got these things. They are Immersion Heater Deluxe. It says it's made in China, but then again everything does these days. But anyhow, so I got these things off of Amazon. Literally the cheapest ones they had. Now, to be fair, I say the cheapest ones they had because they're all the same. Like, they are so obviously all made by the same manufacturer that I'm like, you'd have to be a moron to pay any more money than the cheapest for one of these things because it's the same thing. But you know, I digress, whatever. I use that too much. I gotta come up with my own thing for that. I tried one of these things out. Took one of my good old coffee mugs, stuck her in there, and I even went as far as, you know, cutting open the wire so I could put some testing to it, you know, amperage testing and voltage testing and stuff. And I come to find out the thing draws 10.3 amps. And that's at 12 volts. So 10.3 amps. That's actually a significantly large amount of amperage for a cigarette lighter. The idea was that these things can plug into your cigarette lighter. Here's the point for these, right? For these things. Say you want a hot cup of coffee or you want a hot tea or something like that and you're driving on a trip, then you can totally plug it into your cigarette lighter and, well, let me just take this from Hulk Iron Man, the Hulkbuster here. Now you can go over here. So you can totally take these things, right? You plug it into your cigarette lighter and you just drop it on the rim and it's got a little hook to hang on the rim and it heats your glass of water up. I wouldn't recommend putting anything other than water around the thing because it'll cook whatever else is in there. But for water, it definitely did work. 10.3 amps. I did the calculations. It's over 120 watts of energy that this thing's putting out. That's pretty significant. Like, it's actually kind of impressive for what it's worth. Now, that being said, by the time I was done, the plug-ins, the wires were warm, and just the whole thing seemed kind of shady. For starters, the fuse in most cigarette lighters or 12-volt supplies in cars. Sorry, I'm back from the day when it was actually a cigarette lighter in there. So the fuse in most 12-volt supplies in cars is 10 amps. So if this doesn't blow it, it gets pretty darn close. Which really messed up my idea. Because what I wanted to do is I wanted to... Oops. So what I wanted to do is to be able to plug these things in. I wanted to be able to create something that you could plug into your cigarette lighter and heat your vehicle with. That's kind of a dream. Actually, that's a lot of a dream because every cigarette lighter has a limit of 10 amps and 12 volts, which is 120 watts. And 120 watts is about 409 BTUs. 409 BTUs, well, the computer puts out more than that. And I've got a refrigeration circuit cooling that thing off. It's really not that much energy when it comes to the space of a van. I mean, here's the thing. You put two of them together and we can squeeze out, you know, close to 1,000, well, 800. We can squeeze out a bit over 800 BTUs. So that's getting there. That's almost half a ton. Like, you could maybe heat a very well-insulated vehicle with that. Maybe. But at 20 amps, you're going to be hard up to power that electrically. Like even if you wire it straight to your battery, like with a disconnect, you know, because safety, you're still going to be hard up. Well, basically, let's just say for shits and giggles that you do wire these things up to power right off your battery, or, you know, a high output power supply, then you're gonna have killed your battery in a matter of a few hours. The other side of this is I need to power this two different ways. I'm not going to cut open my existing power supply. I'm not going to cut open my existing system just to wire these things in and see if it works on one battery, because I already know this is a bit of a pipe dream to begin with. But I am going to wire these together in parallel, and I am going to mount them in the water here. I am going to monitor the temperature of the water so that we can then monitor the airflow, like what we're getting as far as discharge. So in other words, I want to see the water get up to like 100 degrees, maybe like 120, and then I should be able to get like 100 degrees out of this, and that will heat a room. So we'll see how that goes, and then I might have to go back to you know, measure the voltage and see how fast the battery's dropping, just to be careful, just to be on the cautious side for that. So that's the plan. That's my bad idea, is to take these incredibly cheap, these were like 17 bucks, by the way, for both of them together. Anyhow, Prime shipping, so that was free. Yes. So I'm going to wire these two heaters up together, and I'm going to mount them in the water so that they heat up the water, and then we're going to circulate that around and turn this into a heater and see how it performs. All right. So let's see how this mess works. All right. So we've got the 2 units wired in. Now you'll notice I put them on these here connectors because, like I said, I don't trust the cigarette outlet. It was getting a bit warm, so I don't trust that. So this is a bit more reliable. So we're going to plug those in. I have my temperature sensor here to judge the temperature of the water. As soon as I see the water hit to like 120 degrees, then I will plug in the fan, circulate the water, and at that point, we're going to watch the water temperature to see how much the water temperature drops, or if it stays, you know, stabilizes and then still gains. It should drop. Like, there should eventually reach an equilibrium. This radiator is definitely capable of handling more than 240 watts of energy. What I'm going to do is wait till the water hits about 120 degrees. That's the ideal temperature I'd like to see to heat a space. That's assuming a 20-degree difference across the radiator, which we don't know that's what it'll do, but we're going to shoot for the stars and maybe hit the moon, right? So without further ado, let's go ahead and set this up. And here goes nothing. All right, we definitely have current movement, and now we just wait for the temperature to go up. So this may take a while. So I'm going to go ahead and jump ahead at this point to the point to which it actually has the water heated up, because I don't know how long this is going to take. So I'll just jump ahead so that you guys see the end result. Okay, so I'm a bit disappointed at this point. My battery power supply here just simply doesn't have the balls to run this stupid thing. Sad to say. But you know what? I have a different idea. Not to be outdone. We're not going to give up at this point. I say maybe I'll have to heat some water up and see how it goes. I'm going to go boil some water, and then we'll put it in there just to see how good of a heater this thing works. Alrighty now then, so the battery, using the battery to run these here water heaters, that didn't work out. That didn't work out very well at all. But not to be deterred, I want to see this thing, or at least prove to you guys that if I feed this thing warm water, it'll work as a heater. It's a pretty simple system, or a pretty simple idea, but hey, you know what? Sometimes you just have to prove an idea, I guess. So I have boiled a bunch of water. So we're going to add this boiled water to the water we have in here. Oh, if I can actually get it in there. I guess I spilled a little bit. All right, now our water is about 105 degrees and dropping quickly. Okay, so this isn't going to last very long, but we're going to take our sensor out, dry it off, plug this thing in, and see what kind of heat we get out of it. Alright, so I got a supply air temperature of about 79, 80 degrees, and our ambient temperature is much lower. Dropping and dropping and dropping and dropping. Oh, look at that. 70, 71 degrees. So a 10 degree split. Again, we have a 10 degree split. But here's the more important thing. So we got a 10 degree rise in here. Now, that may not seem like much, but that would actually heat a space. And on top of that, let's see what our water temperature has come down to in that period of time. 97 degrees. So in a matter of minutes, we've dropped 10 degree water temperature. Now I'd say we have roughly a couple gallons of water in here. So whatever the mass, there's a calculation again. I'm not going to do it because I'm lazy, but so here's the gist of it. If you're going to use electric heaters to warm up the water, it's going to take a significant amount of electricity. Given that it takes a significant amount of electricity, you're either one, going to, like, this is more electricity than your solar system can power. Say you have a 100-watt solar panel. Like on average, I've seen an average, you know, these camper vans that people live in usually have a 100-watt solar panel, right? So let's say you have a 100-watt solar panel. That can't power even one of these heaters because they're 120-watt heaters. It's not enough juice. So you'd have to have a 250 to 300 watt solar system just to power two of these heaters. Then it might work. But here's the other side. That's during the day. Then what do you do at night when it actually gets cold? So you're left with two choices, right? You're either going to run the engine to be able to power your electric system, but at that point the engine's already running, so why not just run the heat? Or run a generator. If you're running a generator, well, then you have significantly more options to heat a space, such as a 110-volt space heater, infrared space heaters. Anyhow, you have an infinite amount of options as far as 110-volt heaters in advance. So essentially, the whole idea of using these here submersion electric heaters to turn this into a heater just really isn't a good one. So long story short, these here immersion electric heaters are not a good option to heat or make one of these things a space heater. It uses too much energy to accomplish the task. Now that being said, I do have an idea, like a stretch of an idea in my head that might just work. And this will take a bit more creativity than simply throwing together some mishmash. Like, this might be a moderately challenging build. And it involves using a campfire style, like you got to set up a campfire and then run water hoses to the campfire, essentially using the campfire as an on-demand boiler. At which point that would heat the water, and then you can put the water, obviously move the water from the campfire into the house using the pump, or the van using the pump, which would then give you heat in your space without having to have combustibles actually in the vehicle. That's the whole idea, is to avoid having combustibles in the vehicle. Now I realize there's lots of other options out there. There's these diesel heater gadgets. I got to look into those and stuff. But so our first attempt at creating a space heater for mobile situations like living in your van hasn't worked out so well. But that's not the end of the story. We're going to come up with some better options and hopefully some interesting, if not decent options to accomplish the job in your vehicle. So keep an eye out for those videos. Again, thank you guys for watching. Even though this wasn't a success, we at least learned what not to do. So I appreciate you guys watching thus far. Go ahead and throw a thumbs up there if you like this video or if it was informative or anything. Make sure you subscribe for future videos when we do have the successes, that you can learn from those successes and maybe, integrate that into your own situation you got going on there. And hit that bell icon so you get a notification of that. Again, thank you very much for watching. I greatly appreciate it. And you guys have a good night.
Bye-bye. Fighting with, because apparently Windows has done bricked my computer again. I am so fed up with Windows. God. Really, I'm fed up with a lot of things. Apple can't seem to leave shit alone, and they brick everything, and now Windows is like, oh, hey, let's join the club. Apple's is bricking everything, so let's us brick everything. Urgh. Anyhow, yeah, I'm gonna go boil a pot of water and add it to this thing. At least then we can see, if this makes a decent heater or not. All right, I'll be back.